Assalamu alaikum students. Hope you are doing good things in your life. Our today's topic is of chapter number 16 and it is diode. Basically students, we know about the diode that it is a two-terminal device that is formed by joining a p-type and n-type semiconductor materials. So we will write it is a two-terminal device formed by joining a p-type and an n-type semiconductor material. So we will say that it's a two-pin device P and N. As we have discussed in our earlier classes, what is a p-type device and what is an n-type device, how we'll make n-type semiconductor, how we'll make p-type semiconductor. For that you have to see my previous lecture. So now we have discussed that a diode is a two-terminal device that is formed by joining a p-type and an n-type semiconductor material, and it only permits the flow of electrons in one direction. So we'll write that it only allows flow of current in one direction. So in it, current can only flow in a single direction, and that direction when we have to bias it in forward biasing. We will discuss earlier that what is the forward biasing. Now let us discuss first that what is biasing. So students, biasing is just an arrangement made in diode or in transistor or in any other device to allow larger flow of current in certain direction. Like in diode, our certain direction is forward biasing. So we'll write that biasing in diode, it is an arrangement by which device can allow larger flow of current in a certain direction. For the biasing, we have to see other things too, like because of the p-type and n-type semiconductor used, so the majority of the p-type carriers are holes. Majority of carriers in p-type semiconductor material are holes, and majority of n-type semiconductor material contains electrons. So majority of carriers are electrons in n-type, and for p-type the majority carriers are holes. And when we have to tell about the diode, about its making, so we have to tell that this is of the p-type and this is for the n type, and this is a symbol to draw. So let us see the internal structure of the diode. In diode there are two type of materials used. One is the p type and other is the n type, and we know that in p type the majority of the carriers are holes, and in n type the majority of the carriers are electrons, and in between there is a depletion layer. So now it depends upon the connection of that internal circuit. For suppose if we connect the p type with the positive terminal, so the depletion layer gets on decreasing, and when we connect the p type with the negative terminal, the depletion layer gets on increasing, means it gets on thickening. So we can write that thickness of the depletion layer depends upon so we are saying that thickness of the depletion layer depends upon the biasing. If it is forward bias, so the depletion layer will be thin. If it is reverse bias, so depletion layer will be thick. We'll see that how the things are working in the diode. So let us consider this diode is forward biased. So we'll write that let us consider the forward biasing of diode. So in forward biasing, what we have to do is to connect the p type with the positive electrode and n type with the negative electrode. So what will happen when we connect the p type with the positive electrode and n type with the negative electrode, that the positive and positive get repelled each other. So these holes and this positive electrode repel each other. So when they repel each other, so the depletion layer formed is very thin. So it gets on decreasing, and it will have the flow of current in one direction, means it will have that flow of direction. So because this positive plate can repel this p holes, so they will jump over the n side, and that is how the current flows in forward biasing, because of the electrostatic repulsion. Because of, we will write that because of electrostatic repulsion, the depletion layer gets on decreasing. Depletion layer gets on decreasing, and thus current flows. We'll write thus current flows, and only in forward biasing the current can flow. Now let us connect this circuit as the reverse biasing. So as discussed earlier, in reverse biasing, the p-type terminal is connected with the negative terminal, and n-type terminal is n-type material is connected with the positive terminal. So what will happen, that there will be electrostatic attraction in between them. So now in this reverse biasing there is electrostatic attraction between charges. So this positive charge can attract this negative charge, and hence this depletion layer gets on increasing. So we'll write that depletion layer gets on increasing. So that is how the reverse biasing is, and in reverse biasing no current flows. So now let us conclude about the reverse biasing and forward biasing. So now let us quickly conclude about the forward and reverse biasing. In forward biasing, we know that the current flows. How current flows? That we connect the p-type terminal, p-type material with the positive terminal, and n-type material with the negative electrode. So we have seen it. Now in forward biasing there is electrostatic repulsion, and because of that electrostatic repulsion the current flows. And in reverse biasing there is no current flow, there isn't any flow of current, and p type material is connected with the negative terminal and n type material is connected with the positive terminal. So because of that there is an electrostatic attraction, and because of that electrostatic attraction there the potential barrier is larger and the potential barrier is smaller. I hope you have understood the lecture. Thank you.